Hi everyone, I wanted to finish off this look at templating, and I will fully admit right now the templating thing did not work as easily as I would expect it to. And this is the kind of thing I discover every single term, and you might discover the same thing. One of the problems with templating is that I still believe that the syntax is really kind of wonky. So before I get going on this, let me just reiterate or at least explain, state explicitly, I will not be having a big exam question involving templating. There might be a multiple choice or something, but templating, if you want to practice templating, start with something small like a hash table and then go from there, because the refactoring I had to do on this code base that we just did, I'm glad I copied everything over. It was arduous, to say the least. It was real pain, including every aspect of it. And what I kept on discovering over and over again, this is the second time re-recording this video. I got the templating to work. I had everything. I was demonstrating everything. I worked through a bunch of examples. I tried to change what data type I was going to put in the stacks, and then for the life of me, got stuck and couldn't figure it out. I had to go, Google things, and I had to, figure out exactly what the syntax looked like. It was quite a pain. The reason I want to point this out is that is one of the tragic flaws of templating. It's great when people actually can use your templates, but actually implementing these things is not trivial by any stretch. It's not trivial because the syntax looks weird. I had a weird bug last time, though I stopped and I said I was going to show you the end result. Yeah, I did. I got to read my own instructions a bit more carefully too, and I read it and was like, that can't be right. It seriously is. I'll show you the instruction in a second, but it seriously is as crazy as it looks. And then after all of so is said and done, I make a brand new type of object, put it on my stack, trying to demonstrate it off, and then realize I can't print off the information for that stack unless I override what the double chevron, the two angled brackets in a row, that operation does. Right? It was not easy by any stretch, because you won't find the problem until you go and try the new approach. If I try and make a brand new class to put onto a stack, and I don't implement that particular method, I'm only going to find the error when I try to put the new method on there. It's a just-in-time error message that you keep on getting every single time. Every time I make a change to the code, I might be calling a function that I never called before. It was implemented, but I never called it, and I'll only find the problems then. So let me point out the crazy pants, absolutely crazy thing. Oh, I gotta do it in this mode. That was what got me. I know you can make a templated function. I know you can make a templated class. The fact that you cannot make a templated function in your CPP file is really strange, and it's because it's not, and you won't notice it. You'll just keep on getting weird errors. You won't notice it until you'll get a linking error at the very end. Not while you're changing the syntax, not when you're doing this or that. Only at the 11th hour, when you're thinking everything's done, you've done all of this work to migrate everything over, you'll find out that you have a linking error. Because templating requires you to know where everything is, and it needs to be able to generate new code. As a side effect, or one of the limitations of C++, the definition of the function, not just the declaration, not the little stubby line, but the full implementation of that function must be in the header file, not in the CPP file. You can actually get rid of all of your CPP files if you go to a template, or all the ones that involve a template in the end. So that I find very strange. So what does it do? And here's an example of it, but it didn't quite click in when I was looking at it, that this might be a function defined within the header file, but it was like, oh, well, that's just because it's one line. No, every function, no matter how long it is, must be fully declared and defined in the header file, not in the CPP file. It means the code is not as modular. It feels like a very big kludge when it comes to the code, but so we'll have a look at that in action. So this would be me making a header file which has all the definitions for all the different functions. Here I am using this is another header file, And then I point out, hey, look, I have a constructor, and look, they have this templated thing. But this is a templated function outside, not in the CPP file, and that's what threw me off. So let's have a look at this. Let's keep that because it just said the word seriously. And we're going to look over at this function. In case you're wondering, Linkless Demo, LinkedList Demo is a lot smaller, more modular, easier to read file. It was what I did last term, but since we kept on adding to LinkedList, the implementation this term is a lot more convoluted. That doesn't mean it's not more useful to look at. You can look at either one of them, whatever works for you. So here is what my linked list. Notice here are my source files. I have two CPP files in total. One has my main. One has a brand new class called Payload, just because I wanted something. And then the rest of it, everything got moved over because if every single one of my linked lists and the child classes and the nodes for the linked list and the iterators and the stacks, everything using a linked list, if all of those need templates, all of my code is just in the CPP file, in the header file. So here's linklist.h. All of my code, every last bit of my code is in the header file. It was this little prototype like this, but instead I needed to go and it looks like I normally would have. I have this template on the top saying I'm going to have a template. Here is start is a template, and everywhere in my functions, every one of my functions, if I needed a template like here, right? This is a templated version of a node. So everywhere I had a node, I put T afterwards. Everywhere I had a this, I put T. Everywhere I had an iterator, I put T afterwards. It was sort of ridiculous amount of editing. I'm putting a T afterwards. If I need to insert a node, put a T afterwards. I still have the word virtual, right, like I had before, but now I have to define the actual function in my header file. And that means that if I make any changes here, I have to rebuild everything all over again. It's extremely slow. In terms of compilation, you can go off, have a sandwich. That was the old way. You just to dread changing your header file because it required you changing everything afterwards. Here is, I'm adding a piece of data, so I'm going to make a new node. I'm adding a piece of data. It's going to end up being an integer in our case, and then I'm generating a pointer to this linked list node, which stores a templated value inside of it, and that's what I return. Right? If I'm finding the data, I take in the data I'm looking for, and I return the node that has that data templated inside of it. And that T is everywhere in all my code. Get the last node templated. Get the previous node templated. Here is my destructor, and I have to template those things. Right? My operator, I template that thing. Let me see if I have a good other example in here. Here's my iterator. Get the start iterator. The iterator is templated as well. Everything is templated. Every single one of these classes, if I use any class, I had to put a T in front of it. After it. But every single one of these things, the thing I'm returning is an iterator, linked list iterator with a T of type T. And you can go to any one of these things like linked list iterator.h. It's a templated file. Here's the friend file. It's a templated class. And all I'm doing is I'm going to get the next. I might get the particular value that I'm looking at. All of this stuff, but I could not find it. Like, it took a while to find this bug, just because you get a linking error, this unclear linking error at the end, rather than getting some kind of clear that this is a syntax error, because it's trying to make brand new files that it didn't have before. I find it a little wonky. Anyways, so that's all I had before. And so my demo, I have my horrible print thing. Here is me using a templated function. I pass in a linked list that takes linked list object or pointer to a linked list that is of type that stores data types T. And so I have to say, okay, by the way, I'm going to define this data type T later. So I'm going to get the iterator, and I'm going to do what I had before, but everywhere I had any of these objects, again, I put a T. The only place I don't put a T is when I actually want to commit to something. So I'll look at this one here. I'm making a linked list of integers. That's what this thing does. And so every time I call something with a linked list, for this particular linked list, it will make linked lists of integers. All the functions will be regenerated for integers rather than for some other data type. So if I call, let's say, so I'm making a linked list of integers, so I make a constructor. It would behind the scenes, it's going to make a constructor for linked lists that only take integers. It's going to make a function that inserts only integers. It's going to have a print list function for integers. It will essentially make a whole new class of linked list stuff, but only for integers. If I put another data type in there, it'll make an all new set of classes just for that data type. In fact, that's what I'm about to do. So here's what my original plan was. So let's change it back to what it was before. Int, and I'm going to change it to 2, 3, 4, 5. These are just, I'm going to make a bunch. I had a bunch of payloads, but I'm just going to make a stack of integers. All right, that's all I'm doing. I'll need to recompile everything. Fine. Let's run this. Great. I make a stack of integers. That's all I have. Okay. Now let's change it one more time, and let's call this P. I'm going to make a bunch of brand new classes. I made a brand new class called Payload because it's the data carrying stuff, and I'm going to make a stack of payloads. All right. So I make a bunch of payloads one after the other. I make a brand new, and then I push each of those payloads onto the stack. Okay. So let's also break some stuff as well. So I'm going to get rid of this line here. I'm going to get rid of, and I'm going to get rid of, let's just, I think it's K, right? No, damn it. I always forget what the comment out all instruction is. You guys pointed it out. I was very excited to see it. I always forget it now. There you go. Close enough. I'm going to get an error. But I only get an error after I try to make a payload with like I tried to make a default payload without setting anything up. It's because linked list node makes a payload thing that's going to be, it's making a whole bunch of arrays. Because I have some kind of default payload, until I actually, how do I describe this? Because I have a default payload, or I need a default payload, I'll get this bug, I'll get this error, but only when I actually try and run the code or compile the code at the end. It won't, if I'm not actually making this call, if I'm not actually doing this, it's not a syntax error in my payload code. It's only there. It shows up in weird places. All right, so let's put that back in. This is me overloading the constructor. I'm making two constructors, one that takes nothing, one that takes a value. That's polymorphism, another type of polymorphism. And I can compile it, and then I'll also show you what went horribly wrong the last time. All right, and if I go back up here, hey, it looks about the same. The numbers are slightly different, but everything worked the way it did before. It worked the way it did before because, oh, darn it. Sorry. It worked the way it did before just because I had to figure out how to make it work. It doesn't care what type of data it is. Before I had an integer, and what I forgot about is that integer, I sort of painted myself into a corner here. I probably should have had it store some type of object and have that object do some kind of printout method. Because I was storing integers everywhere, it meant I had to be able to support cout statements straight into, like, I had to be able to go cout. Let me show you an example. Where's my oh, that's the, I want to see where my cout statement is. Let's see. No, that's the cout. destructor, print list. Okay, here we go. I'm going to get the particular data. So I get the data type T, and then I'm calling cout on it. Before I didn't even do that, so I can move this around, and instead, hopefully it's going to work. Right? I'm going to output node ID and then the node. Before I would get the data, it was an integer, and cout works like you expect. If it was a string, cout would work just fine. I don't need to do anything special. But since I made a brand new object, and it wasn't implementing what this operation here was doing, the dealing with the output stream and the double chevron, because of that I had to hack in some solution. That is not the ideal approach. The ideal approach might be every single thing I put into I make only classes. I don't use just an integer, and so instead of integers everywhere, I'd be putting in a class, and every one of those classes has a printout statement. That might have been easier for me, but as a result, I had to sort of painted myself into a corner. So this is what I had to do. I had to overload again the double chevron operator. This is taking an O stream. I will not be asking this on the exam, but this is me taking the O stream as one of the parameters, taking the data I'm going to print out as one of the parameters, and outputting it to the O stream. This is what is actually happening with integers and strings. I just had to do it for my particular class. I had to use polymorphism for this, because I had to override what it was doing before. This is method overriding, or operator overriding. My payload method, my paint method does this, and essentially I'm just outputting the data on this. So if I wanted to do is this, and let's do that. Override. I'm just going to put the word override in between each time. Why? Because I can. Let's compile it. Let's run it. And let's override. Yeah, I've hooked into how cout actually works, but that it was ugly and very difficult to do. Here's the thing. How do I know that they're in the right order? If I wanted to insert data in the correct order, I might need to do something else. So let's go back. Hopefully this is going to work for us. I'm back to improvising some stuff here. So this thing is going to take in a bunch of data. It's going to insert these values, each one after the other. And what I really wanted to do is let's see if I can do that directly. Insert payload, this. Notice it's not, this thing doesn't store payload, so it's going to be a problem for right now at least. Give me a second and I'll get it working. So it's going to insert this payload. And we should hit a problem here. Also, this is going to make an integer payload for double linked list. That should be fine. This is going to be making an integer payload, or a linked list for payload. And this is an integer list for a payload. Alright, hopefully this is it should blow up in one place in particular. Can I convert from this to this? Okay, so this is a linked list with of type payload, and this is, darn it. It's an array of linked lists. Okay, I need to change this as well. So this is my array of linked lists. I need to payload. I'm going to change that here. I am going to go down here. So instead of storing a number, I'm going to make a brand new object each time. Well, it's temporary, at least, just within here. I didn't call new. I didn't call new, so I don't have to call delete afterwards. I'm just putting in payloads for each one of these things instead of an integer. But each of those payloads stores an integer. Okay, and then afterwards it's going to be taking type payload, and this, where's my other thing, type payload. All right, cannot convert from this to this, and I need, so I'm going to remove from the end, and my return value, see, it will find mistakes after the fact, which is terrible, really, really terrible. There we go. Didn't even tell me that I did something stupid there. I'm removing for the end, I get an integer, I get some data type, and a return. But since I was using integers all that other time for my doubly linked list, it didn't find it. Okay, this is what I thought I was going to have as an error. I need to be able to override this. I'm getting my data, I'm doing the comparison operator. So I'm actually going to just save this thing here. I'm doing my comparison operator, checking to see if this data item return is less than this. But I'm comparing two objects. The thing this thing is returning is a payload. This is a payload. I need to compare two payloads with this operator. And this is actually what I wanted to point out. If I have templated classes, there are certain guarantees that that templated class must adhere to. If I say I can do a less than operator, I better be damn sure I can do a less than operator. If it says it needs to be able to call a method called print data, it needs to be supporting the method print data. Whatever the case is, I need it to do that. So I'm going to go back to my payload operator. I'm going to put in, so what I'm going to need is I'm going to need this operator. I'm going to override this operator. I'm not taking in a linked list or anything. I just copied and pasted. It's a payload, and this is the thing it's going to compare to. And I'm going to override it in my C++, in my CPP file, and just like I did previously. So I am, instead of the normal operator, I am overriding what that less than sign does so that it works with what I have. So what I need to do is this, whatever I'm currently at, the value of this one is less than to compare dot value. That's what I want to check. That's what I want to return. So I'm going to return that. Notice, oh, I have one other problem. Oh, here's my other problem. Oh, I fixed it. Darn it. Notice what I had to do here. Ideally, in an ideal world, if I did this, again, which val am I talking about here? Which val am I talking about here? In both cases, it's this val here. The this operator says the member variable val, make it equal to this value here. That's one of those weird bugs that can pop up. In this case, since there's no local variable called val, it means the member variable. In this case, since there's no local variable val, it means the member variable. In this case, it's the variable val in this other object. And that way I know which val I'm talking about. I always am worried about disambiguating what version of things I have. All right, let's see, what am I doing here? So I'm going to get the data, that's type T. It's going to get the data, type T. And that should have done it. So let's have a quick gander at this. T D1. Just because I want to. Oh no, it's to compare. And I want to say D1, D2, and let's see what happens here, because that should. As 2 compares a dot. Oh, it's double equals. See how what ends up happening? I keep on having to make more and more operators. There's another operator I need to override, right? I need to figure out that this thing is equal to that thing. So I'm going to go to this, and I'm going to override this one as well. Hopefully there's not too many more of these. But this was the problem of starting with an integer and not starting with an object. Because starting with an object, it would have been very explicit what I need to do each and every time. Starting with an integer, it's not so obvious. So double equals, double equals. All right, this should be about the same thing. There we go. And everything works just like it did before, presumably. Yeah, it looks like it's working the exact same way as it was working before. I could have also made it so that instead of calling this cout statement, I could make it force it to call some kind of some kind of printing method. So, print out the value or see out the value or something like that. And I could, if I made that, then every single payload or every single class that has this needs to implement those functions. The idea is, I don't know what these functions need. I'm just saying I need some kind of class. And if I call something like equals, or I call a particular function for that templated class, anything that wants to be, a type of data that goes in there has to be supported. So if I say I need to call the paint method, I could have an array or linked lists of shapes. If I try and put anything that doesn't have a paint method, it wouldn't let me put that item. I wouldn't be allowed to make a linked list of that type of item. If it supports the paint method, then I could. It figures it out on the fly at the last minute though, and that's where the real quirkiness of templated values are. It was to the point that I didn't even want to teach that. Anyways, that's neither here nor there. We're gonna stop the video now, and then when we come back next time, we're gonna be looking at why we actually have these templated classes. We'll be looking at the standard template library, and in that case, you get to finally use those templated classes and sort of reap the benefits of having a template without having to actually make your own, which is a pain. We'll also be looking at sorting and searching as well. So that's something very exciting to look forward to. Thanks, everyone.